Welcome to this tutorial for Bayesian Assurance and nQuery. In this tutorial, we will cover a Bayesian Assurance calculation where the researchers were using a two-sample t-test sample size calculation and show how Bayesian Assurance can give you additional context for how likely the trial is actually to succeed. Bayesian Assurance, sometimes referred to Bayesian power, extends to traditional power calculation by allowing us to pre-specify a possible range of values for our effect size. We do this by using a prior distribution for the effect size. We then average the power over all the potential values based on that prior and get a better estimate for how likely we are to actually get a significant p-value, given that prior understanding of how likely different effect sizes are to occur. In this way, we get closer to something that might be considered the true probability of success for our trial based on our prior uncertainty around the effect size. In nQuery, an assurance calculation will usually consist of two parts. First, we will require the inputs that were used for the original sample size calculation. In this case, we're going to use a sample size calculation for the comparison of two means taken from the New England Journal of Medicine, where they were comparing cyclophosphamide to placebo for the treatment of scleroderma disease. While in the original study they used a significance level of 0.05 at a two-sided level, in an assurance calculation we would usually recommend using the equivalent one-sided analysis by halving alpha and setting it to a one-sided analysis, due to the fact that an assurance calculation is more likely to be affected by power from the lower tail. In other words, effect sizes in the opposite sign of the original expected effect size. And in practical terms, in a clinical trial, we usually are not interested in those. In their case, they wanted a prior mean difference of 9 and had assumed that the standard deviations were equal to 16 in each group. In this case, we are assuming that the standard deviations in each group are known exactly and are equal to 16. They had required a sample size of 68 per group for 90% power, giving a posterior variance for the difference of 7.529. This is simply equal to the square of the standard error from your simple two-sample z-test or t-test. To do our assurance calculation, we need to specify a prior for the effect size. And a simple prior would be to assume a normal distribution which is centered on the expected mean difference of 9 and then with a customized variance for that normal distribution prior. In this case, we simply need to set the prior variance of the difference to an appropriate value based on other data, for example from a pilot study, or based on elicitation of opinions of the expected variance in our original estimate from experts or similar. In this case, let's assume that based on prior research we had an uncertainty around the mean difference characterized by a normal distribution with a variance of 10. In this case, we can see that the assurance is equal to 0.807 on the proportion scale, or 80.7% on the percentage scale. That's approximately a 10% decrease versus the original target power. And this is expected since we are now considering a range of mean differences which are below the original target power of 9. In a simple power calculation, we are assuming that the mean difference is either 9 or higher, but obviously those other considerations where it's lower are more accurately reflected in this assurance calculation, and thus you may want to consider the assurance to be the true probability of success for your trial, in this case success being defined as getting a significant p-value. The maximum assurance is simply the value for the assurance that you would get with infinite sample size, since due to the definition of assurance we are ignoring the lower tail in this case. Assurance calculations can take on a number of different forms even for the same test. If we wanted to extend our example where we had prior uncertainty around not only the mean difference but also the standard deviations, we can do that by assuming that those standard deviations came from a sample size or internal pilot of a given group. For example, here we can see the same study except where the standard deviation estimate of 16 had come from a prior sample size, say an internal pilot, of size 25. And in that case, the assurance would only be 73.9%. We can also have a custom prior where we choose to place a certain probability on certain fixed effect sizes and see what effect that would have. For example, here we take mean differences ranging from 7 to 11 with these probabilities of occurring in our prior, and under this assumption we get an assurance of around 87.1%, a much smaller reduction, as in this case we can see that the lower effect sizes are relatively less likely than the original effect size or effect sizes that are higher, 40% versus 60% being at or above our original effect size of 9. To learn more, visit statsolves.com. Thank you for watching.